All right. Go for it, Kenny. Looking forward to
Thank
it.
you, Dr. Cashin. I'm actually honored to be here, talking to you guys in the honors program. Last time I did this was probably about 5 years ago, and do the simulation program. But I'm honored to be back. I was going to see how many times I can say the word honored in the same word. This is a presentation that I've actually modified. I did something similar to this about a year ago for a place event that was jointly between us and NTCC. I didn't allow NTCC. Because I implemented some 3D printers down there, and we're going to do the same thing here. As a matter of fact, our printers are actually on order, so they're actually supposed to be here about a week ago, but anyways, when they get here, I'll let you guys all know. You guys can come down to the Bass building, and I'll show them to you, okay? Show you how it works. I don't care if you came for the presentation or the food. You know, anytime you've got food with a presentation, everything goes great. But guess what, y'all? I also brought toys.
Yes.
Toys too, which I will pass around the toys here in a little while, okay? I brought toys, you know, show and tell and that kind of stuff. So that always goes well whether my presentation doesn't amount to hill beans or not. Hopefully you guys will be impressed. Anyways, let's talk about 3D printing and rapid prototyping. These are things we're going to cover. One thing I want to point out to you guys is the key thing about engineering is all about design. All about design. From the very first course I teach our engineers in the engineering program about intro to engineering, we start talking about the engineering design process. I'm blessed now that I'm back to also teach our seniors. And the thing we talk about there for 2 semesters is the engineering design process. The coordinating board in Texas is part of the ACGM for all the lower division courses, spell out exactly what some of the SLOs need to be. Well, the SLOs for engineering graphics, which I teach, are the ability to do rapid prototyping, engineering design, and using rapid prototyping. So that's key to what we do in engineering. What is prototyping? Believe it or not, GM and Ford now use prototyping, use big 3Ds, they use smaller 3D models, but they use big 3D models on their concept cars. Saves them a lot of time, a lot of money, especially if something doesn't work. So what's prototyping, and why would you want to do it fast? Why would you want to do it rapidly? You know? It's usually the things that we enjoy in life, like a vacation, a cruise, a trip to Hawaii, whatever, we want to just take our time. But so why would you want to do it fast, okay? And usually there's actually a long-term time between design, fabrication, and production. Typically engineers, and this is back in the day when I first started at the Army Depot back in the 80s, we'd actually design something, send our drawings to the machine shop. They'd actually build the part. We'd go back, we'd test it and find out, oh no, the tolerance is off, it doesn't fit, it doesn't work. Let's go back and do it again. Redesign, go back to the machine shop. Finally, after about 2 or 3 weeks, maybe a month, we had a working design. With 3D printing, we're able to do that a whole lot quicker. We can do that in the space of 2 or 3 class periods. The Last Jedi, okay? Movie came out, what, Christmas 2017? I know we're all waiting for the next one. It's supposed to come out maybe this Christmas 2019. There was a line from it. I remember watching the movie. You've got Yoda talking to Luke Skywalker there on the island, and all of a sudden, he makes this statement that I've been telling my students for a long time. The greatest teacher failure is. In other words, we learn more as human beings, as students, from our failures than our successes. If you went through your whole degree program and all you did was just succeed, and you would never grow. You know, that's part of growth also. You know, any living being, any plant, it's just overcoming adversity, okay? And if we don't fail and learn to fail and overcome that failure and realize it's just a part of life, we'll never grow and we'll never be successful in our profession, okay? So what rapid prototyping is, you know, essentially, you know, over here, it took us some time to figure out we failed. But what rapid prototyping is, allows us to fail faster. Okay? Really, it allows us to fail faster. And this is a picture of some failures, okay? If you make a failure, either about how you got your materials, whether it adheres to your bottom plate on your 3D printer, to your heated bed, if it doesn't, you'll end up with a bunch of fishing line. Okay, so, but it does allow you to do it rather than take 3 or 4 weeks to say, I made a mess. really quickly, okay? And of course, when you start to print, you want to keep watching at the beginning to make sure everything's working right, like exactly right. Rapid prototyping is an iterative process. It's all about continuous improvement. I remember, this is a process back I didn't like learning in college. It wasn't until I got to the Army Depot, was actually an engineer, that Deming, Toyota production model, total quality management came into being, okay? And we all started talking about continuous improvement, which is part of everything we do. It's part of everything you do in your degree program, whether you know it, here at the university, okay? And assessment and improvement. That's the same thing in the engineering process. We want to continually improve. Take, for instance, an iPhone, okay? An iPhone went from a smartphone, if you got an Android too, went from something very basic to something really, really fancy now. And Apple is always improving it. Matter of fact, they'll even put some out on the market, and they'll continue to improve the operating system or the features of it, okay, through iOS. They're able to do that way too, okay? So continuous improvement is part of everything we do, especially the engineering design process. The definition of 3D printing is actually the process by which the object is printed by laying down successive layers of material. And it's actually, and I always forget, it's FFF, and I always, you think, well, there's already teachers, you should know this, but I always forget it. It doesn't want to stick in my mind. It's called fused filament fabrication, okay? In other words, you're depositing a small amount of whatever it is, plastic, in some cases human cells, sometimes concrete, to actually build something in a layer, okay? Starting off the first layer and then building up. The advantages, of course, are reduced time, cost, and risk, and increased flexibility, customization, and efficiency, okay? Because you can actually change things a lot quicker. Applications, we'll walk through some of these. Biomedical, industrial, architectural, military and aerospace, and academic, okay? So here we have some bioprinting, okay? They bioprint now skin tissue, cartilage, and body parts. Some of our pathology professors can talk better to this than I can, but essentially, you know, they grow skin cells, your own cells, in the lab. And what they do is they have a media that actually ties a group of cells together, and they're able to actually take that media and place it, you know, around either a substrate or some kind of structure to actually build something like a cartilage for an ear. They've actually done kidneys. I don't think they've got a working kidney yet, but they've actually started having kidneys with your cells. So the goal is one day, if you have to have a kidney transplant, it can be your own kidney grown from your own cells. So that's the goal. Now, a lot of cartilage and that kind of stuff is, ears, noses, that kind of stuff, that works really, really well, cartilage does. In industry, okay, you can build molds, dies, parts, fixtures. A lot of these are big, big units. They use a process called laser sintering and some metal powder to do it all, but you actually can quickly make parts. Usually smaller parts, nothing really giant, but smaller parts. And these machines, you can tell, it's really tied really heavily to robotics. And everything we do in math is all X and Y and then the Z axis, okay? And the same thing here, okay? And that's the way the robot moves. And that's what we're doing, just change the positions of that print head to where we want to deposit that material. 3D printed house. Dr. Paul Bahai, NCC, put me onto this. Happened last year, Austin, Texas. A company called Icon, okay? The machine they use is called a Vulcan. Happened in March 2018, it's 650 square feet, cost $10,000, took 24 hours to do it. This is actually the finished structure here. Small house, made in concrete, just layered out. Now, it looks great. Now, they did not, they've gone through the process of testing it. It doesn't have a lot of, it's not something I would put in a hurricane zone because there's not a whole lot of reinforcement in the concrete. You know, it's not concrete block and steel or anything like that. But it is some way to do it real quickly. Now, also another kind of negative is, of course, the plumbing and the electrical has to be, you know, stuck on the walls on the inside. So they're not internal to the wall structure or anything like that. But that is a way to quickly build a concrete structure, okay? With this device they call Icon Vulcan. And actually Google it, you can actually drive by and see it. I haven't driven by and seen it in Austin, but you can go visit this thing if you so desire. Military and aerospace applications. They do replacement parts and also do things in remote locations. This on the left, right here, this is a grenade launcher. The barrel and receiver were made of aluminum using direct metal laser sintering process that uses high-powered precision lasers to heat the parts of the powder below their melting point, essentially welding the fine material powder layer by layer until a finished object is formed. This right here was actually done in the International Space Station. This is actually testing a 3D printer using relatively low temperature plastic feedstock on the International Space Station. So they do it both in military and space applications. And guess what? I was getting this, polishing up this presentation for you guys, doing some research, and sure enough, right now, this month, they just did this in Camp Pendleton. The Marines did. Built their first 3D printed bridge. It took them 14 hours. Okay, what they did is offsite. If you can see this picture, I put these three pictures kind of together. It's kind of hard to see from the back here. They've actually got a boom here where their concrete is, and they're laying it together in forms, and their structures laying on top. It took 14 hours to do that, and then they took the parts and they assembled them together. They ended up making a footbridge. It's supposed to take a load of 15,000 pounds. There's actually some YouTube videos on this. The major that was actually overseeing this project, he said it's actually originally built to take a personnel vehicle. That's why it's rated 15,000 pounds. They're going to actually do load testing either this week or next week. But their goal is, if this works, they're going to start building full-size ones. This is something that they feel like they can take out into the field and build a bridge quickly. The whole thing took, I'm going to set notes on this one too, 14 total hours for the concrete printer to run and make the components. Components took 36 hours to cure, so they could cure overnight. 4 hours time for assembling components. So really the total time is 3 8-hour days, because all they work is 8-hour days, was 24 hours to build the bridge. So that's something very, very current. The technology is always changing. Now we get academic applications. How does this affect us? Okay, and it affects us in engineering graphic design. These are some different types of 3D printers. 3D printers can print in all different shapes, sizes, applications, whether it might be industrial, educational, hobbies. A lot of people have them at home. The features that you usually find on a 3D printer is some kind of interface panel. Some kind of really nice interface panel. Either a dual extruder or a single extruder. The ones I had in CCC were dual extruders. They would do a PLA plastic. PLA plastic, excuse me, the green PLA plastic, which is more like, it's kind of a sugary, sucrose-based, it's biodegradable plastic, okay? You get a lot of good detail out of it. It's a little bit more brittle than ABS plastic. ABS plastic is actually Lego plastic. Lego plastic. So I'm going to send these around, and what's neat, and you'll see a couple pictures in a few minutes of how these actually get designed. Sure. And I'll start some others from this other side so you guys can see those. I've got several different examples. Again, the green is the PLA and the white is the ABS. These are more solids here. You might note here on the bottoms, this is some of the first parts I made. I took one of the 3D printers home and I used it for about a month and looked at it. And you can tell I didn't get these really adhere to the bed. This is exactly right. You get the bed's heated. You've got to get the adherence really good so the thing doesn't want to slide around, and then so forth it builds in the Z direction. But you know, it can build too. Different filament types of support. You can have filament from a cellulose-based filament to a metal-based filament to plastics. Different types of plastics to different types of rubbers. Okay, and it all depends on what kind of heated nozzle you've got, what type of heated bed. Of course, heated beds and non-heated beds. Okay, PLA, the green stuff, you can print pretty much without having to have a heated bed. ABS does require heated bed. Okay, and we're talking about temperatures in the range of about 200 degrees Fahrenheit. Okay, some will have Wi-Fi. Some have SD cards. Some have USB. Some have cameras. I'll show you here in a few minutes the one that a couple I've got ordered for us have built-in cameras, heated beds, so we can do some different stuff with them. And where on Wi-Fi, if I'm at the house and I want to see if something's going wrong on one of them, I can just look at it and see what's printed, which is a really nice feature to have, especially if you're in another room or someplace else on campus. This is the filament. And the filament can be, like I said, PLA, ABS, and I've got a slide that defines what these are, for those of you guys who are interested in the chemistry, okay? Wood, metal, and carbon fiber, okay? It comes in all kinds of varieties of colors. Got these spools. So here's the two that I have actually got ordered for us, and hopefully in about 2 weeks you can come down to the Bass building and see them, okay? This is both made by Flash Forge. We actually do have a MakerBot replicator right now in our senior design lab. The bed is not heated, and there's some problems with the bed leveling. That's another thing you've got when you have a 3D printer. If the bed's not exactly level, most of them are manually leveled, then your print head knows what its X, Y, and Z is, and it assumes the bed is level too. So both of those have to work really well together. But here, this one right here, what's nice about this baby right here, it prints in rubber, plastic, wood, PLA, ABS, a single head. It's got a real nice interface right here. There's USB, there's Wi-Fi. This one's got a camera in it also. So that one's really nice. This runs around about $2,000 a piece. Hopefully one have a couple of these. This one right here is one that you may want to have at the house. This one strictly does PLA. This one runs around about $300 a piece. You can get both of these on Amazon if you so desire, okay? And they do anything that you, the green stuff that I've got, you might, I've read online some people have tried to do ABS, but this thing does not have a heated bed. But this thing also has USB, and I believe it does have Wi-Fi also. No camera though in it, okay, for $300. You're paying more on the camera. We'll be using these to support our senior design, and also our engineering graphics classes too. This is actually how it works. This is kind of a blow-up I've included. You've got filament coming off the spool, going through kind of a pinch system right here that pulls the filament through, and then gets heated up and deposited on your part. So depending on, and of course, the head moves in a XY direction this way, okay? And then the bed moves up and down in the Z direction too, okay? So it can actually be fixed depending on how big your part is, or it actually can move up and down, okay? Now what's nice is after we design, I'm maybe getting ahead of myself, some of you guys were holding up everything and kind of looking at it really closely. And here is a couple of copies, and I'll send it around, of some that I had oopses on, mistakes. And all you guys were looking at the nice little hexagonal pattern that's in it, okay? Believe it or not, the software does it all. We design our parts in Autodesk Inventor, take it to the slicing software, and actually we'll do that. And I can change what these are if I want. I can override them. I can make them squares. I can make this thing solid. But if I make this thing solid, this thing takes about an hour and a half, hour and 15 minutes to run just like it is. If I were making it a solid, it'd probably take about 6 hours. So I'm going to send these around. These are mistakes. I saved my mistakes too. I thought this handy to have. I'll send this one this way and this one this way. We'll get some through this one. I'm looking for my clicker. Keep with me. So what we do is we go through and in the Autodesk Inventor, we design this part, the one that you guys see in your hands, okay? We design that part in Inventor, and then we take it to flash print, okay? I did this on a Flash Forge Dreamer. This actually has jewel extruders. We may end up getting with all of those in the future. But anyways, you put your part in. All you do is you have to save this. It's the thing called STL extension on the file name. It's interpreted by this, creates this, and what's nice is when we design here, we design to scale. Even if we're designing a car, we design it to scale. But then we bring it in here, in the software, we can scale it up, we can scale it down, we can stretch it, we can do anything. We can move it around this bed, and this actually shows the envelope that we're designing. This shows you the maximum we can use of that printed surface. And this software is called Flash Print, but they make it for all the different versions of printers. Okay, so you can't go wrong. Probably the most important thing is whenever you do this, you got to make sure that you just click a couple of little things there and make sure that this thing is actually sitting on the bed. Because actually, when you do design in 3 dimensions, sometimes you design and you may be this much above something in the Z direction, and you got nothing. You're trying to deposit material in space, and it doesn't work. Okay. And by the way, this is called slicing software. The reason why you call it slicing software is you actually take this software, and I can actually show you, if I had it on this computer, I can actually show the different levels that it actually will lay, all the different slices. This software will tell me how much plastic it's going to use up, how many hours it's going to take to print the thing, before I even start. So it's kind of nice. This is kind of the daddy version that I ordered for us. And it does both PLA, ABS, and several others. But this is actually, for you chemistry buffs, this is what PLA means. It's polylactic acid. And it's usually from renewable sources such as cornstarch, sugarcane, is biodegradable. ABS is acrylonitrile butadiene styrene. Okay? In other words, Lego plastic. Okay? It's insoluble water. Okay? It's got a build volume. This one does a lot bigger than the smaller red one. Is of 11 inches by 9.8 by 11.8. Almost, not quite, a 12 by 12 block, which is pretty big. Okay? You can always do stuff diagonal too and get something bigger if you need to. Bed temperatures go between 120 degrees Fahrenheit for PLA and 220 for ABS. A whole lot hotter. Okay? Nozzle temperatures go from 390 for PLA, ABS 430. You don't want to stick your hands in there, get close to that nozzle. I've gotten burned, even though I know I'm not supposed to. So I've learned the hard way, okay? Because it will definitely burn you, okay?
Red hot.
Yes. Anybody have any questions? Oh, by the way, before I get to questions, you guys can ask questions. We pass around some more toys. Now, I cheated. There's some stuff that I actually pulled off the internet, because there was all kinds of stuff you got on the internet. These are fascinating. And this is my goal, to be able to design one of these myself for our students. You can actually print this little wrench, it works, and then PLA in one printing. There's some knockouts and stuff that you print after you print it, you knock it out, and it actually will work. So I'll pass that around. This one I did ABS. The bed heat was heated a little bit too much, so some of it melted together, so it doesn't really work like the other one. Okay. So I'll send those. I'm going to start these at the back. People at the back feel slided, don't they? Also, this is just the filament. This is how the filament comes. And I'll send it around. This is PLA is the, and you feel free to bend it or whatever too. I'll get some more of it. And this is ABS. Okay. And of course, I keep on telling you, it's Lego plastic. I actually made some Legos, so you guys can look at the Legos. These have real tight tolerance, so they will actually come up. Sometimes it's hard to get them back together. Feel free to take them apart or whatever. So I'll start these over here. I think that's pretty much it. Does anybody have any questions whatsoever? And we're right on time, so you feel free if you need to leave, go ahead and leave. But if anybody wants to talk technology or technical stuff, I'd be glad to talk to you.
I had a question.
Sure.
Oh, actually, my son had a question.
Okay.
About wood.
Oh, how does it print wood?
Okay, do you know, have you ever been to some of these parks like in Dallas? Like either the zoo or maybe the Fort Worth Zoo or something like that. You've got these benches. They're kind of plastic, but they're wooden too. They last like forever. They're kind of brownish. Well, there's a combination of plastic and cellulose together, some wood fiber. That's the same thing this thing does. It's got some wood fiber amongst some plastic, so therefore it heats the plastic up and deposits. So you've got actually something that's not really wood like we think of a tree or a board, but it's a combination of plastic and wood. And they call it wood fiber.
Pulp almost?
Sir?
Like pulp?
Yeah. The pulp is mixed in with some of the plastic. It's basically just a binder for it. Yes.
You know,
Yes, sir.
when you're printing the wood, when the wood spool goes in the laser, how does the wood not catch fire? Does the plastic act like some sort of heat insulator?
It actually somehow I have not actually done it myself, so I can't tell you. I haven't actually observed it. I'm sure here because we're enterprising, we'll probably get some just to see what it's going to look like. But I would guess it's going to be it's a temperature you've got to not exceed a certain amount. And these printers are really, really good. As far as they know, you can key in there in the software exactly what you're printing with, and it'll keep that head temperature range to that limit. So something going any higher than that. But you're exactly right. You probably have a smaller window with that. But even with the I don't think I brought anything that had it, but even with the ABS, 220 degrees Fahrenheit, I have had some on the bottom that I had the bed heated a little bit too much, and you see kind of a darkish, brownish, blackish spot where it actually burned it. So you can actually burn the stuff, yeah. Sure enough. Good question.
What's the cost for a roll of filament?
Raw filament runs, if you get it on sale, you might get it for 25 bucks. If you don't, they might come as much as 50. And you have to watch what kind of weight you get too. Usually they come in kilogram spools. They come by weight. A lot of the 25 or 20 buck ones are like 3/4 of a kilogram spool. And that kilogram spool, depending on what the parts you want to run, oh gee whiz, could run you 3 to 6 months, you know. Now, with stuff we're doing, I'm expecting we'll do a whole lot more, so I've actually added a bunch of additional spools. And of course with different colors and that kind of stuff we can use too. So I'm so sorry. I'm
No, you're fine. I'm back here now.
Yes, I'm moving too much.
It's okay. Makes it dynamic. All right, David.
Back in November, I attended a conference, and one of the presentations was actually a biologist from the University of North Georgia, and they had created an interdisciplinary maker space with a lot of 3D printing. And what he was showing us was that he had taken some of the skulls, as mammalogists, he had taken some of the skulls, and he had, rather than having students handle the real thing, he had 3D printed the skulls where they could use them in the lab. Actually, Simon 3D printed me an inner ear a couple of years ago because somebody took one off from the model. But I was just thinking, what about a future plan, maybe a makerspace, be a great recruiting tool?
Yes. Without getting too much detail, because it hadn't happened yet, I worked on a little project last week that there is a benefactor of ours in town that wants to give us a substantial amount of money for an engineering graphics lab. And we'd approached them at the beginning of last semester and it didn't work out, but now, last week, said, we got the money, so you got to come up with it. So I came up with a bunch of equipment, one of those being a camera system to digitize stuff in. So if we get that, we'll be able to do that and reproduce some of those parts you want to produce.
Well, even Dr. Occasion could 3D print his own castle.
Yeah, that'd be awesome.
Yes. Yes.
3D print me a castle, Kenny.
I wanted to share it with anybody, because if we can make use of it throughout the whole university, that's all the better, you know? Some of you guys want to come sit in class, you're welcome to do that too, yes.
Is the FlashForge AI, or not AI, UI similar to the MakerBot UI for the...
It is. The MakerBot's just a lot more expensive, and sometimes it doesn't do everything that these do.
Yeah.
And that's the difference I found, is they just want, because of their name, and they're the industry standard, they all want a lot more money for their stuff.
They both will all work with all the different CAD files?
Yes,
and
they sure will.
The objects?
They sure will, And by the way, I forgot to say in my presentation, I had it written down, that last year, Dr. Allard, he emailed me. He knew I was making this presentation up, and there was actually a professor in England that was proposing that they put 3D printers and CAD software in all the classrooms in the United Kingdom, in all of them. Because they said, early on, we need to start with that kind of stuff. And a lot of our schools do have some of those there, you know. So it's a shame. Like I said, we will have some. Like I said, we've got some that we're going to use in our graphics class this semester, but hopefully this benefactor comes through with us, we'll have a real nice setup. Because I even spec'd out really nice curved screen workstations and that kind of stuff, for computers and that kind of stuff, so we can do stuff at a big scale. And we'll get a lot more of these printers, okay? Hopefully, by the end of next week, we'll have 8. We have 1 now, hopefully we'll have 8. And that will make it where it's nice for a class of 24 of mine, which I've got now. But hopefully in the future, we'll have maybe 15 or 20 of them, okay? And we can go to, and the reason being, it takes some time to print each part. But you guys go ahead and leave if you need to leave, because I know you guys have class.
Thank you very much, Kenny. Well done. Yes, return the 3D printed toys. Thank you.
And if you want a toy print, if you want to ever get them, let me know and I'll print you a toy. Okay?